Here's another example. And the example is to prove that 3 to the power of 4n plus 2 plus 2 times 4 to the power of 3n plus 1 is divisible, now these are getting harder, by 17 for all integral n greater than or equal to 1. So it's 3 to the power of 4n plus 2 plus 2 times 4 to the power of 3n plus 1 is divisible by 17. For all integral n greater than or equal to 1, can you have a go, girls? Step 1, step 2, step 3. Right, when n is 1 and do it, then you must say therefore true for n is 1. Do you know what I mean? Yeah. Or you can just write prove true for n is 1. You'll see some past HSC solutions how they do it, alright? So prove true for n is 1. Let's go. I can just go 1 instead of writing step. What do we? We'll call it integers. Okay, 3 to the what? You'll have to work this one out. Plus 2 to the 4, 2 times 4 to the 4. And that's definitely not 8 to the power of 4, please. It's 2 times 4 to the power of 4. What's that? 6? No, it's not.
17 times 73. Oh. It's 729 plus 512.
Which is?
1,241.
1,000. So all you do is on your calculator, you go divide it by 17 and hope that you get a whole number. 17 times 73. So I think for that one you'd need to show that it's 17 times 73, which is... Okay, so we've proven it's true for n equals 1. Step 2, assume true for n is k. Now I haven't done the even and the odd ones yet. I might just leave them for tomorrow, okay, because I really think we need a couple of lessons on each type, all right? We want to do it properly. And there's also all other types as well. So assume true for n is k. In other words, we are assuming that, I'm just going to make some room, 3. You can see how important it is. Equals what?
You have to write assume true for k.
You know what, you probably don't assume that that equals, you could probably just write that. So assume that that equals what? 17p. Doesn't matter which one, where p is an integer. That's what we're assuming, that it's 17p. Sorry? It's a good idea. No, not, yeah, I think you're probably going to do 3 to the 4k. I don't know if I'd be expanding that yet. Let's just see what happens. Yeah. Prove true for n equals k plus 1. Let's hope this is not too hard. In other words, we're trying to prove that, be careful here, that 3 times 4 bracket k plus 1 plus 2 plus 2 bracket 4, 3 to the k plus 1. I mean, that is divisible by 17. Yeah, I forgot it. Get me the white stuff, please. We're trying to see, I'd be careful with what I've done there. I'm going to fix it in a minute. So we're trying to prove that 3 times 4 to the k plus 1 in brackets plus 2 plus 2 times 4 to the 3 k plus 1 in brackets plus 1 is divisible by 17. Instead of rewriting that again, I've just gone straight to the next line. 3, 4k plus 4 plus 2 plus 2 times 4, 3k plus 3 plus 1 equals. Now, What are you trying to substitute? You're going to try and substitute 3, 4k plus 2. So see this 2, I want to put it there. I'm going to write this as 3. Watch what I'm doing. 4k plus 2 times 3 to the 4. See, all I've done here is swap the 2 and the 4. Do you see what I'm doing? No. If you add them, you can't make the substitution from step 2.
So can't you write 4k plus 6?
Alright, if you do that, what are you going to substitute from step 2? The only thing you can substitute from step 2 is 3 to the 4k plus 2. So what I want to do is swap the 2 and the 4 around so that I've got 4k plus 2. I'm going to keep that together, then times it by 3 to the 4. Alright? Plus 2 bracket 4. There's no reason why you can't add these now. 3k plus 4, which equals, now we make the substitution. 3 to the 4k plus 4 plus 2. If I write 4k plus 6, forget making a substitution. So I'm going to swap the 2 and the 4 around. I've got 3k plus 2 times 3 to the 4. What would happen here? The bases are the same. Add 4k plus 2 plus 4 is the same as that top row. But I've swapped the order of this 2 and 4 so that I can substitute. Otherwise, I can't make a substitution. So obviously, we're going to substitute 3 to the 4k plus 2, that's all in powers there, equals 17p minus 2 bracket 4, 3 to the k plus 1. That's what I'm substituting. Which equals, what do I write? Can I put the 3 to the 4 at the front? What's 3 to the 4? 81 bracket 17p 3 to the 4. I like, because it's something times something else, it's going to be a number times the bracket. Let's put the number in front of the bracket. 17p minus 2 bracket 4 to the 3k plus 1 plus 2 bracket 4 to the 3k plus 4. Look, we still might make it. I'm thinking of actually making this 3k plus 1 so I can combine some terms here. All right, so we'll look at that a little bit later. Is this 81 only times the first thing, isn't it? Which is, I'm going to have to start spreading this all out. Now, can you keep it written? We're trying to show it's divisible by 17. Don't go multiplying 17 by 81 now and then you've got to undo it. Just keep it as 17 times 81p. Are you okay with that? If I go 17 times 81 and you come to the last step, I've got to divide it back by 17 anyway. Minus, what's 81 times 2? 162 bracket 4 to the 3k plus 1 plus. Now girls, I need to do something here. I can't, can someone close the door? Like terms, 4 to the 3k plus 4 and 4 to the 3k plus 1 are not like terms. I can make them look like terms as follows. 4 to the 3k plus 1 times 4 to the what? No. 3. Because what's 3k plus 1 plus 3? In other words, I should never have done this up here in hindsight. Alright, so I've got, actually I'm going to leave lines now because it's just getting very squishy. 17 times 81p minus 162, 4 to the power of 3k plus 1 plus, what's 2 times 4 cubed? See, that and that are whole numbers. 4 cubed is 64. It's 128 times 4, 3k plus 1. Isn't that looking better? Which is 17 times 81p. Now, minus or plus? We've got two like terms now.
Oh, yeah.
What? Negative 34. Great, because that's 17 times 2. 4 to the 3k plus 1. Close bracket. All right. I couldn't do anything with this the way it was. I had a 4 to the 3k plus 1 and a 4 to the 3k plus 4. So I've decided to break that up to make it 4 to the 3k plus 1 plus 3. And now I've got like terms. Now 4 to the power of 3 is just a number, which is 64. So I've got 64 times 2 is 128. So now 17 bracket 81p minus 2 bracket 4 to the 3k plus 1, which is 17 times q, where q equals that all that bit in there. Girls, you're trying to, obviously we don't want different powers here, it's not going to help us. Alright, neither of these numbers is divisible by 17, so we've got to do something. So, summary, if, going back to step 2 with the assumption, if it's true for n equals k, then it is also true for n equals k plus 1, since it is true for n equals 1, then it is also true for n is 1 plus 1, which is 2, 2 plus 1, which is 3, etc. Alright? And so on. For a divisibility one, we've got the odd and the even type as well. So,
Next, miss.
you don't want to watch a video tonight at all, do you?
No.